Alright, we're going to look at another example here of converting Cartesian form to polar form, and this time theta is going to be in degrees. We want theta as an answer in degrees. So we've got Cartesian form here, and this is my x, this is my y, and polar form, as you can recall, is r and theta, and this time we want theta in degrees. So I think a very good place to start is to put this on an Argand diagram. So we've got our real axis and our imaginary axis. Now, this is my x, -1, and -2. Instead of going up this way, we're going to go down 2 units. So this is -2. So here is my z, and at the moment we've got it in Cartesian form. So this is the -1 and -2. So we need to come up with the polar form, and this is my r value, and this is my theta value. Theta always starts with the positive direction of the real axis, and it goes anti-clockwise. Okay, first thing I think to calculate always is r, and r is equal to the mod of z, and that's just equal to the square root of x squared plus y squared. We've already identified that x is equal to -1, so it's a square root of -1 squared plus y is -2. So it'll be -2 squared, and that's equal to the square root of 1 plus 4, which is equal to √5. So that is my r value. So we've got half the polar form done. We've got that. Now we've got to work out theta. Now theta, if it is in degrees, if this is 0, it's 90, this is 180, and this is 270. So I think by doing a diagram, you can always see the range that you're going to be looking for theta. If it's in degrees, we should expect to get an answer between 180 and 270. And I like to calculate this angle here, alpha. And all I've got to do to find out what theta is to add 180 degrees onto alpha. So, if you like, I'm going to redraw this little triangle here, down below. And I know that this is 1 unit, because if this is the origin, it has come out to -1. So I'm going to disregard the sign at this stage, because I'm only trying to work out this angle here, alpha. And I know I've come down 2 units. So once again, disregard the sign. So to find out alpha, we know that the tan of alpha is opposite over adjacent. So that's 2 on 1. So alpha is the angle whose tan is 2 on 1, or just 2. Now, if you put that into your calculator, you push Shift tan, and when you go Shift tan, it should open a bracket, and you put 2 divided by 1, close the bracket. You get alpha is equal to 63.4 degrees if your calculator is set in degree mode. Now that's not theta. That is just the angle that it makes with the x-axis there. So that is alpha. So looking at the diagram up above, we know that what we've got to do to get theta is, to this alpha here, we've got to add 180 degrees. So we've got theta is equal to 180 degrees plus 63.4 degrees. And that's going to be equal to 243.4 degrees. We've now got the 2 components that go to make up the polar form. So now we can say that -1, -2i is equivalent in polar form to an r value of √5 and a theta value of 243.4 degrees.